Hi everyone! Today I want to present to you our new Python package for fast and easy multimedia processing, Boombox. This tool allows for transformation of multimedia streams between formats, such as MP4 or WebRTC, in just few lines of code. It also allows for interacting with the streams with Python code, opening up plenty possibilities for audio and video analysis and manipulation, for example using AI. Boombox at its core is a tool written in Elixir that is based on our multimedia framework, Membrane. The Python package is essentially a wrapper around it, allowing for easy integration with Python projects with no prior knowledge of Elixir required. I will now show some simple examples. First, we have to install the package with pip install. It's as simple as installing any other Python package. I already have it installed, so I'll skip this step. Now that we have our package installed, I'll introduce the basics. The core of the package is the Boombox class. We define the way we want our stream to be transformed by instantiating this class. We have to specify what format the input stream will have and what format do we want the output stream to have. We do that with endpoints. An endpoint is simply an object that defines such format. For example, if you want to have a Boombox that transforms an MP4 file into an HLS playlist, we have to pass appropriate endpoints when constructing the Boombox object. We set the first argument, the input, to an MP4 endpoint with the location of the file specified. Then we set the second argument, the output, to an HLS endpoint with the location where the playlist will be created. We will also call the wait method, so that the program finishes only once the conversion is finished. As we can see, if I play the resulting playlist with some player, like VLC or FFplay, the video is played as expected. Instead of endpoint objects, you can also pass bare strings, and Boombox will try to infer the endpoint from their file extension or scheme. I will now show how to interact with media streams through our code directly. To do that, I will use two Boomboxes. One will read an MP4 file and provide the raw frames from it to Python. We'll modify these frames, and the second Boombox will read the modified frames from Python and write them to another MP4 file. To read and write the raw frames, we need to use the raw data endpoint, which enables the methods used for this process. If we use it to define an output of Boombox, then the read method will become available. This method yields media packets that we can interact with. This means that if we use a for loop, like so, then the packet variable will contain a new frame each iteration. If we define an input with raw data, then we'll need to provide packets for Boombox with write method. To showcase what can be done with a stream, we'll invert the colors with a simple trick. The video packets contain RGB images as 3D NumPy arrays. If we subtract each pixel value from 255, then we'll get an inverted image, which we'll write to the second Boombox. Once we're finished, we have to tell Boombox that we're done sending him packets with close method. It will then finish its operation and return. As we can see, with just these few lines, we got an inverted video. In place of this simple operation, you can do anything you want. Process the video with AI, transform it with OpenCV, or something entirely different. It's really up to you. Finally, I'll showcase our more advanced demo, which is available on our GitHub and you can run and test yourself. This demo takes a WebRTC stream from a browser, transforms it with AI to anonymize it, and streams it to another browser, also with WebRTC. To activate the anonymization, I have to raise my hand. When I hold my hand above my head, my face becomes blurred, my voice becomes distorted, and my words are being transcribed, everything being streamed with low latency WebRTC. That's the last thing I'll show today, so if you're interested, you can visit our GitHub and docs to dive deeper. You can also play around with the demo, which is also available on our GitHub. Thanks for watching, bye!